guys, welcome to my channel. So let's see today's Leetcode challenge. So today's challenge is to find is to actually remove the nth node from the end of the list. It's the list is a linked list. We have a in the example we are given this linked list. Okay, so 1, 2, 3, 4, 5, where each node is linked to the other node, and this last node is right. This is a head node. So in the question, it is asked that given a number n, given a number n, we have to remove the nth node from the list from the end. So in this case, the second node from the end is, this is the end, from the end is 4. So we have to remove this. Now the question is pretty much clear. Everything is simple. So a basic naive approach that we can go through is simply we can do is we can have a while loop, okay, and we can iterate over all the elements of the node, and we can find the length of the linked list. And let's say our length of the linked list is n. Okay. Now to delete the second node from the end, we can say that to get this second element from the beginning, we have this formula n minus n plus 1. So let's say n is a 5 in this, and given small n is 2, so 5 minus 2 plus 1 will get this 4. So we will get this fourth element, the one that you have to delete. So in one iteration, we can get the length of the linked list, and in the second iteration, we can iterate till 4 minus 1 till here, and then we can linked list. And in the second iteration, we are basically making this link from 3 to 5. So this whole algo will take our of 2 and 9. So using the concept of slow and fast pointer, how can we approach to this question? Okay, so let's see. Okay, so using the slow and fast pointer, what we generally do is we maintain the slow and fast pointer, slow and fast, and we initialize them with head. Now let's think that we have 2 pointers, okay, and we need to get the position of this index so that I can delete this link and directly link this 3 with 5. Okay. Now, if I have this 2 pointers, what can I do? So generally in the slow and fast concept, what we do is we iterate this slow by 1 and this fast by 2. But that we are not going to use it here. We can use another way. So one approach we can use is, let's say we have a n equals to 2. Okay, so what if I iterate this fast pointer 2 times? So in the first case, okay, let's see, this is a link. At first time, our fast pointer will be here. Let's say slow pointer is somewhere given this. Okay. So n equals to 2, for the first n equals to 1, we have this fast pointer to head. Now, n equals to 2 will increment our fast pointer to 2. Now, we got our n equals to 2. 1 done, 2 done. Next thing, once we have completed this n equals to 2, what we will do is, we will in the next term, we will now start our slow pointer also. So in the next term, fast will be on 3 and slow will be, and this we will do till we don't get a fast pointer to the end of the linked list. So in the next turn, a fast will come here and a slow will go on second. And in the next turn, a fast will come on 5 and a slow will come on 3. And this is exactly what we wanted. We wanted this 3 so that we can remove this link and we can directly link the 3 with 5. So this is pretty much clear. Now let's talk about the edge cases. So in the edge cases, let's say we have a n, okay, equals to the length of the linked list. Okay, we have 1 and 2. Okay, and the n is 2. In that case, what will happen is, we'll traverse the fast. Our slow will be initialized to head, our fast will be initialized to head. So in the first iteration, fast will be here. Okay. Second iteration, fast will be here. And now we got n equals to 2. And our slow is also here. So once we got n equals to 2, but the next thing is null. After 2, we will have a null. So we can't go further. And now we can have slow pointer to 1 or anything else. So once that loop of iterating from the start of the linked list to the end of the linked list is over, what we'll do, we'll check that if we'll check this n if n equals to capital N. Now I'll show you the code. So in the code, when we'll be iterating from 1 to 2, we will also keep n variable so that we will traverse from 1 to this small n. And each time we will be iterating in the linked list, we will keep updating our n. So we will check if this is a small n equals to a capital N, then what we can do is we can simply return heads. So in this, what's happening is we have to remove this one, and 1 is nothing but the head pointer. So we can what we can do is we can simply return a another case. Let's say a linked list is empty. So in that case, if the linked list is empty, we will in that case also we will return our head because head is initially pointing to null pointer. Okay, so this is our code section, right? So as I told you, like if our head is null or heads next is null, okay. So either we have no element in the linked list or we have only one element in the linked list, we'll simply return null. Okay. Next, what I'm doing, I'm maintaining this slow and fast pointer. Okay. Now, in the next section, this int n equals to 1, what is this? This is nothing but to check, like I told you, that we'll maintain a variable capital N, okay. And like since we have to start this slow pointer, once we have reached this total n, so we are maintaining this capital N, and every time in each iteration we are updating this capital N's value. Okay. So what we are doing is, if this capital N is greater than small n, then I'm starting my slow pointer also. Okay. Else I'm just iterating my fast pointer. Okay. And this we are doing until we are not getting the fast next equals to null. Now once this while loop is completed, okay, I'll check if a capital N, okay, equals to small n, then I'm returning this small next. Else if, one more thing, else if s next equals to null. Okay, I am returning s next equals to null. Why? So let's say I got this value, okay, and the next of 4 is 5 and the next of 5 is null. Okay, so s next will be null. So instead of assessing that null, I'm directly returning this s next equals to null. Okay, sorry, I'm setting the s next close next equals to null, and then I'll return this. Or if these edge cases don't satisfy, okay, I'll simply do s next, that is 3's next will be set to 3's next. Okay, 3's next set to 3's next. So, and then after that, I'll return this. So let's run our code. It's accepted. Thank you.